So we've reached our end of chapter 7. So 7.6 is the last section that we will be covering. We are going to move on from simplifying radical expressions to solving radical equations. So before we go on to solving these algebraically, I want to remind you of what you're doing. So if I have an equation that says what the square root of what is equal to 4, hopefully you know that the what is 16. If I ask you the square root of what is negative 4, hopefully you remember that I can't take the square root of a negative number. The value of x has to be greater than or equal to 0. If I can't take the square root of a negative number, then I can't get a negative answer. So this would have no solution. You can show that with an empty set brackets, or you could say no solution. But what happens once I learn how to solve these algebraically? So if I go to solve the square root of x is equal to 4 algebraically means that I'm trying to isolate x. So what's in the way of getting x by itself is the square root sign. So what you want to do is the opposite operation of taking the square root, which is squaring. If I square a square root, I can get rid of it. But I'm not allowed to just square a side of the equation. The power rule states that as long as I square both sides of an equation, I'm allowed to do it. I preserve the equality. So if I square both sides, I would end up with x is equal to 16. Great, that matches. Okay. But if I apply the power rule to this question, which we already said has no solution, because I'm doing this process of squaring, it's going to give me a solution. It's going to give me that x is equal to 16. But we know that this can't be a solution. So down here, there's a little explanation. And what it is that using the power rule to solve algebraically doesn't necessarily give you an equation or a solution that's true. What it is it gives you what's called a proposed solution. It's your job to determine if it is a solution. How do we determine if something is a solution? Well, we check into the original equation. So we've got square root of x is equal to negative 4. If I plug in 16 for x, I get positive 4. So it didn't work. So then it's my job to reject that solution and actually state that there is no solution. So this 16 is a proposed solution. Since it didn't work in my original equation, we call this an extraneous solution. Okay, so let's move on to solving algebraically. So the whole point of that is that when you solve algebraically, every solution is only a proposed solution. It's your job to determine if it is a true solution or if it's extraneous. To solve a radical equation, first step is to isolate the radical. So if you look at this question here, it's already got an isolated radical on the left-hand side. I'm going to show you why you have to isolate in a minute, but I just want to show a simple example first. So isolate your radical. Done. Step 2, apply the power rule. What that means is that you're going to raise each side of the equation to a power that's the same as the index of the radical. Now, we are only going to be solving square root equations. This textbook does solve cubed root equations as well. You can solve fourth root equations, but it's not an articulated outcome. So we're going to focus on solving square root equations, okay, but the process is the same. So here we go. We are going to square the square root. What we do on one side, we do to the other side. And so the squaring of a square root gets rid of it. We end up with x plus 2 is equal to x squared. Now, your job is to determine if this solution is linear, in which case just solve algebraically, or if it's quadratic. If it's quadratic, meaning that the highest exponent on a variable is 2, you have to use the zero factor property. The zero factor property is that you have to set your equation equal to 0 and then factor it. So here I've subtracted x, subtracted 2 from both sides. I end up with 0 equals x squared minus x minus 2. Now that I have it equal to 0, I can factor it. So I'm looking for two numbers that multiply to give me negative 2 and add to give me negative 1. So that'd be negative 2 and positive 1. Because my coefficient was a 1, I can go straight into my brackets. So x minus 2, x plus 1. If you're still doing the whole AC method for these trinomials, please feel free. Do it somewhere else. Do it on the side of a piece of paper so that it doesn't make your work super convoluted, or do. Totally up to you. So once you've set it equal to 0 and you've factored, now you're going to set each factor equal to 0 and solve. So one of the factors is x minus 2 equal to 0, so x is 2, and then x plus 1 equals 0, so x is negative 1. Now remember, these are proposed solutions. It's up to us to determine if they're true solutions or if they're extraneous. To do that, we plug it into the original equation. When I plug in x is 2, I get the square root of 4, which is 2, and that's equal to 2. It's true. So that is definitely a solution. When I plug in negative 1, I get the square root of negative 1 plus 2 equal to negative 1. Now, even right here, I could stop. I know that I can never take the square root of a positive number and get a negative solution. So I know that this one's going to be false right here. If I keep going, I get 1 equals negative 1, and it's false. So then I'm going to state my true solution set, which is just 2. Okay, let's try 2. First example, I've got the square root of x plus 2 is equal to 3. So I'm going to isolate my radical on one side. Done. Now I'm going to apply my power rule, so I'm going to square both sides and solve. So the square of square root of x plus 2 is just x plus 2, and then 3 squared is 9. To solve this, I'm going to subtract 2 from each side, and I get x equals 7. Don't forget that this is a proposed solution, so now I'm going to check it. I've got the square root of 7 plus 2. Does that equal 3? Well, this is the square root of 9, which is 3. So that is in my solution set. Okay, with this one, looking at this right now, okay, I can't solve it. I have to isolate my radical first, and I'll show you in a second why, but let's just do it. So I'm going to subtract 1 from each side. I end up with the square root of 4x plus 5 equals negative 1. Now, maybe right now you can look at this question and know to stop. You could look at this and be like, nope, there's not going to be a solution because a square root is never going to equal a negative number. Now, if you don't see that, if you keep going and you apply your power rule, you'll end up with 4x plus 5 is equal to 1. We're going to subtract 5 from each side. We get 4x equals negative 4. Divide by 4. You get x equals negative 1. So you get a solution, but this is a proposed solution. So we're going to check it. The square root of 4 times negative 1 plus 5 plus 1, does that equal 0? So remember, always check into your original equation. This is the square root of negative 4 plus 5 is 1 plus 1, which is going to give me 2. So this did not work. And so so there is no solution for this one. So my only choice is to write an empty set. Now I'm going to send you to practice some of these questions, but before I do that, I want to just show you why you have to isolate your radical. So if I were to do this question, let's just keep a simple one. So let's go x, the square root of x is minus 3 is equal to 0. If you don't isolate your radical first, meaning if you don't go the square root of x is 3, square both sides, x equals 9, if you don't do that and you try to solve this, you still have to solve for x by getting rid of the square root sign. So maybe you say, hey, I'm just going to do my power rule now. I'm going to square both sides. Now, you're not squaring every term. You're squaring the entire side. So if I tried to solve it like this, that means that you've got the square root of x minus 3 times the square root of x minus 3, because you're squaring the entire side, not each term. I can't say that enough times. And so if I had done it this way without isolating my radical first, I'm ending up with this crazy like square root of x times square root of x is x, and then I get minus 3 root x minus 3 root x plus 9 equals 0. I didn't get anywhere. Okay, so I've done this algebraic work, but it's not getting me anywhere because I forgot the first step, which is to isolate your radical first. So that's why we do it, because otherwise when you apply your power rule, you end up squaring a binomial, and especially with a radical in there, it really doesn't get you anywhere. So I'm going to suggest that you just watch this one video for now. You can, in your homework right now, do at least questions 1 through 15. So watch this video, do numbers 1 to 15, and then watch the second video.